All right, so the video here, we're going to talk about graphing exponential functions. And again, it's probably something that you studied last year, but also probably something that you need some refreshers on, right? And some just some reminders about what's happening. So, our goal, just so you know, in this class, our goal is to be able to analyze, which would be graph and solve exponential equations and functions without a calculator. And so, the first piece of that is going to be looking at their graphs or the behavior. And I have I've got three exponential graphs here, on this one set of axes. And there's a couple of things that I want you to be aware of. And I think it even, oh yeah, it says in the first example, like, what do they all have in common? I mean, I'm hoping you see right away that all of them go through the exact same point, right? The same y-intercept of 0, 1. And that's because no matter what your kind of expression is, when you have a like 2 to the 0 power or anything raised to that 0 power, you're going to get an output of 1. So all of the exponential graphs or equations will give you, unless you do a translation, will have to go through the point 0, 1 to start with. So that's key. And the other thing I want you to notice that all of these graphs have in common is they don't go negative, right? So the fact that everything's above the x-axis, meaning that no value of x will output anything that's negative or 0 for that matter, tells me that these exponential functions also have a horizontal asymptote. Okay, and that's at y equals 0. So y equals 0 is a horizontal asymptote that all exponential functions in their graphs have. Now, how do you know which graph is which? Well, the behavior of the exponents, the higher or the larger the exponent, the steeper or the faster the curve. So when I see like a 3x, that's the largest of our values here. That's going to be the steepest one. So that'll be the one that's in green. Now, you could also have seen that because instead of writing that as 2 to the 3x, you could have also thought about it as 8 to the x. Think about the difference between 2 to the x, right? When x is 1 up here, your output is 2. But when x is 1 here, your output is 8. So this one's going, 4 times faster than that one. And this when instead of thinking 2 to the 2x, you could be thinking of it as 4 to the x. And in fact, instead of 2 to the 1/2 x, you could also be thinking of it as square root of 2 to the x, because 1/2 as an exponent is the square root power. So the higher the base, or the higher the bigger the exponent, depending on how you view it, would be equivalent to which curve you have. So the one that increases the slowest, this one here, would have to be the smallest exponent or the smallest base if you can make them all x's. So that would be that one right there. Then the next one to the x would be here, and then to the 2x would be there. So again, and these will just be sketches. So I'm just worried about, if you see that, make them, steeper. But again, that's all relative to what you're drawing on your sketch. Okay, now, whether it's 2 to the x or 10 to the x or 4 to the x, like this example, or even e to the x, which we've seen before, your general shape of your exponential graph would be, having a horizontal asymptote. Let me go yellow there, or yellowish color, right? So having a horizontal asymptote, and then drawing a curve that is very close to the asymptote when it's negative, goes through 1 as an intercept, and then is a steep change, increasing without bound, since these are exponential functions. So they might all look alike, but we want to make sure we carefully label them so that we know some data points, so we know exactly where this graph is once we start looking at individual points. So when I graph 4 to the x, again, I would draw like a horizontal asymptote at y equals 0. And then I know that, like if I think even like of a table of values, if I wanted to, like I want to try to label like maybe like 2 or 3 points here. Nope. I keep trying to change the color, and I keep hitting the line width. So I go maybe to blue. So like I know that the general shape is going to be something like this, right? And so I know that it'll be like 0, 1. But then if I let x be 1 here, when x is 1, I have to jump up to 4. And when I let x be 2, I jump up to 16. So I'd like you to label 3 points on these exponential curves to kind of just, just give some scale factor of how steep this slope really is of the graph. Okay. Now, the next one says negative f of x. Because that negative is outside the function, right? Because that negative is outside the function, we know that all of our y values are switching places. So that's going to be a reflection over the y-axis, so over the x-axis, over the line y equals 0. So if you can imagine what that might look like, and again, I'll go ahead and draw just our parent function, right? A 4 to the x would have been something that looked like this. So now reflect that over the y-axis, make it all negative. So then if I do that, maybe pick this color. So our graph is really this. Okay, so there's still a horizontal asymptote at y equals 0. But now instead of 0, 1, it's going to be 0, -1. Because when I put 0 into x, it's 4 to the 0, which is 1. But then we make that negative. And then it's kind of hard to read. Let's do it again. 0, -1. And then when you put in 1, 4 to the 1 is 4, but then make it negative. So it's -4. And when you put in 2, 4 to the 2 is 16, but then we make it negative. And then the other kind of transformation, 4 to the negative x, go here. So all of our x's are switching spaces or places. So that's a reflection over the y-axis instead of the x-axis. So, and again, thinking about your parent function. So if I were to draw just our normal, right, here's our exponential graph. I'm going to reflect that image over the y-axis. So the real answer, or I guess the answer to our problem, would be like this. So again, it's still going to have a horizontal asymptote at y equals 0. Please label that. Still going to go through, in this case, it'll go through 0, 1, because that's on our y-axis, so that stays the same. But now, if I want to get a height of 4, I better choose -1, because then a -1 becomes positive, so that'd be -1, 4. And this up here would be -2, 16. And if you act like, let's say you wanted other points, like maybe you wanted to know what's the value when you put in 1, right? So if I put in 1 there, oops, thought I picked a different color. Let me try that again. So when you put in 1, well, you get 4 to the -1. Remember, 4 to the -1 is the same thing as 1/4. So it's a very small number. It's approaching 0. And in fact, that's why you never become negative as an output, because even when you make your exponent negative, all that does is take reciprocals. It doesn't make things negative. So the only way you would get that negative is if all of a sudden you start doing a transformation. Okay, now there's a lot of examples here that deal with graphing exponential functions. And so, that's what we're going to take a look at and practice in class tomorrow. So I just wanted to give you a head start in thinking about what are characteristics of these exponential functions. You should always look for a horizontal asymptote. And you should always look for like at least a y-intercept, or where would that y-intercept have gone if I start shifting things left or right. But then in addition to that, 2 other anchor points or key points to help us get a good scale of these functions. Okay, so if you have any questions, obviously please come in and ask. Otherwise, we'll finish out the note sheet in class tomorrow.